All right, in this next video, I'm going to go over how we can describe motion. Some of the keywords that we want to know include motion, what a reference point is, and also what the difference is between distance and displacement. So I'm jumping over to slide 18, and we're going to talk about motion first. How do we determine if an object is in motion? We know that an object is in motion because its position is changing, but compared to what? We often use reference points to help us determine if an object is in motion. So if we look at this video of the little boy who's sliding down the slip and slide, behind him, notice there's this tree that's sitting there. Or we could also use the car that's sitting behind him. What we look for is if the position of the object is changing compared to that reference point. So compared to that tree or compared to that car. If the object is getting closer to the reference point or if the object is getting farther away from that reference point, then we can say the object is in motion. So that little boy, as he's sliding on the slide, unfortunately, he is getting closer and closer to the tree. So we can say that the boy is in motion. Now, we can also use objects that are also moving as reference points, but that's mostly used to help us determine if an object is moving faster or slower, right? So if we look at the video on the right-hand side, we have a bear and a duck, and we want to determine, is that bear moving faster or slower than the duck? We would compare just those two objects' motions to each other, and we would say that the bear is moving faster than the duck. Okay, so motion is depending on changing position compared to a reference point. So now we can look at the difference between distance versus displacement. So an object that is in motion, we can measure the distance that they traveled. So every object that's in motion is going to have a starting position. They're going to run around a field. They're going to walk around a building. They're going to go through a grocery store. They're going to drive around town. Wherever they're going, the path that they take to end up at their final position is what we call their distance traveled. In this figure, this is a map of the Detroit Marathon, and a marathon is exactly 26.2 miles, right? So the distance the runners are going to travel is going to be 26.2 miles, even though they started and stopped at the exact same, starting and finishing line. All right, so distance is the total length of their path that they've traveled. Displacement, though, we're going to use the formula, their final position minus their starting position. So in this case of the marathon, their final position was at the finish line and their starting position was at the starting line, but that happened to be the exact same spot. So their final minus their initial position is just 0. Make sure that you include units, though, when you talk about displacement. Another thing to consider with displacement is that you can have a positive displacement or you can have a negative displacement. Having a positive displacement just means that you are or you finished ahead of where you started. If you have a negative displacement, it just means that you started maybe behind from where you started, okay? So displacement and distance. Distance, total everything up, the whole pathway, add every single little interval, add the distances all together. That's how you get the distance traveled. Displacement, we only care about comparing the final to the initial position.